Okay, welcome to 3.2, the mean value theorem, and it is mean, angry. Now I'm just joking, okay? It's mean value theorem, but before we can do the mean value theorem, let's talk about Rolle's theorem. Rolle's theorem says that let f be a function that satisfies the following three hypotheses. F is continuous, f is differentiable, f of a equals f of b, then there is a number c such that f prime of c equals 0. Okay, so Rolle's theorem allows us that if we have a continuous function on a closed interval and you can take the derivative, meaning there's no what? Cusps, no corners, no slopes that are undefined. Okay, so that's what differential means. And f of a equals f of b. Okay, so notice these points are the same. These endpoints are the same. Okay, then if that happens, then somewhere there is a c, somewhere, such that f prime of c equals 0. It means there's a hump. Now this is a horizontal line, which means f prime is always 0, very uninteresting. Here you have 1 point, because one hump. Here you have 2 points, and here you have a 1 point local min there, okay? So we're gonna go ahead and apply Rolle's theorem on this function. So I'm gonna show you how to do that, okay? So number 1 says, f is continuous. Well, this is a polynomial. If you remember back when, we said all polynomials are continuous. Okay? So all polynomials are continuous. So we're good. Number 2, okay? Number 2 says f is differentiable. That means, can you take the derivative? Well, we know from Chapter 2 that polynomials have no cusps, no corners, no infinite slopes, so polynomials are differentiable. Alright, so we fulfilled 2 of the 3 things. So lastly, we want to take f of a and see if it equals f of b. So for part 3, here are your 2 endpoints, so you want to check that interval, closed interval, right? So we want to go ahead and take f of negative 3, and we want to take f of 2. Go ahead and plug those in and see what numbers you get. Okay, so after pausing the video, you should see that you get 5 and you get 5. So f of a equals f of b. All right, so Rolle's theorem, pretty easy. Last thing it says, find all numbers c that satisfies the conditions of Rolle's theorem. So what does that mean? Well, that means we're going to take the derivative and set it equal to 0, our mantra for this particular section, okay, chapter 3. So if we take the derivative here, so we're going to have f prime of x equal to 2x plus 1. Set that equal to 0, you're going to get 2x plus 1 equals 0, so you're going to get negative 1 equals 2x, x equals negative 1/2. So therefore, we know c equals negative 1/2. And we found c, okay? So, any questions on that? Not a big deal, okay? Not that difficult, as long as I give you polynomials, correct? All right, moving on. Why did we learn about Rolle's theorem? That is because we're going to be talking about the mean value theorem. So if you remember, the intermediate value theorem says what? If I have 2 values somewhere on the graph, if I want to know that there's an x-intercept, you plug in those values. If one's positive, one's negative, then it has to cross the x-axis. We learned about the extreme value theorem, meaning what? That there are maximums and minimums on a function. And now we're going to talk about the mean value theorem, and that is if you have a differentiable function on the interval a to b, and there exists a number c such that f prime of c is the slope, or f of b minus f of a equals f prime times b minus a. At some point, the instantaneous velocity equals the average velocity. So that's what the mean value theorem says. Okay, so here's a pictorial example, all right? So, look, here is a line. Here is another line. What do you notice about their slopes? They're equal. Over here, here's a line, here's a line, here's a line. What do you notice about their slopes? They're equal. There is a point where the slope of the tangent line is equal to slope of the secant line. Somewhere on the graph, that exists. That's what the mean value theorem says. Okay? Again, more of a definition question, not so much a problem that we're going to go and solve, okay? But what we are going to do is verify that a function satisfies the mean value theorem on the given interval, then find all numbers C that satisfies the conclusion. So, what we first have to do is, we first have to say it's differentiable, all right? And then we have to find x equals C, all right? Find that number. So, what we're going to do is, first of all, talk about this problem. Square root of x. Can you take the derivative of square root of x? Yes, you know you can. So, f of x is differentiable, okay? And then, so we have f prime of c equal to, again, we're going to go ahead and use the mean value theorem, which says f of b minus f of a over b minus a. So we're going to go ahead and do that. So here are our a's and b's. So we're going to take f of 4 minus f of 0 over 4 minus 0. Okay? So we get square root of 4 minus square root of 0 over 4 minus 0. So that's going to be 2 over 4. So that's going to be 1/2. So we found f prime of c to be 1/2. Okay? So, any questions there? All right, so now what we're going to do is we need to find the derivative, okay? So we're going to take f prime of x, it's going to be 1/2 x to the negative 1/2, that's the derivative of square root of x, okay? So this number right here, we're going to set it equal to that. This is the one time, one of the rare times in chapter 3 you don't set the derivative equal to 0. You're going to set the derivative equal to c, okay? The reason being is it is f prime at c, so we have to find that c, okay? It's in the definition. All right, so we're going to take 1/2 equals 1/2 x to the negative 1/2, okay? All right, so then solve for x, go ahead and solve for x, see what you get. All right, in doing so, you're going to have to multiply both sides by 2. So you're going to get 1 equals x to the negative 1/2. So 1 is 1 over x. Multiply both sides by x. You're going to get x equals 1. And that is your c, which is what you're looking for. So take f prime of c, find your slope, okay, 1/2. Take the derivative, set it equal to that slope, and there is your c. And that is the mean value theorem.